Hi everyone, my name's Emin, and today I'm going to present to you our Blue Sky paper on Computational Social Choice, Research and Development, or in short, COMSOC-R&D. So in order to talk about what COMSOC-R&D means, let's first talk about COMSOC. So computational social choice, or COMSOC, studies collective decision-making problems. In other words, given access to preferences of individuals that might potentially disagree with each other, we'd like to develop principled methods of mapping these preferences into a single collective outcome. And while we develop these methods, we care about properties such as fair representation, or computational efficiency, or robustness to different kinds of manipulation, and so on and so forth. And COMSOC problems are inspired by and have important applications to settings like participatory budgeting, resource allocation, recommendation systems, and many more different settings. However, in part due to its roots in theoretical computer science, econ, and mathematics, a lot of the work in COMSOC remains to be foundational theoretical work with axiomatic and algorithmic results, and this degree of abstraction sometimes leads to a fundamental disconnect between the theory and its applications to real-world problems. This is where COMSOC-R&D comes into play. But what is COMSOC-R&D? In short, it is a problem-driven research agenda that thinks of COMSOC as an engineering discipline that designs, implements, and tests collective decision-making methods in the real world. Importantly, not only is the goal of COMSOC R&D projects to deploy solutions to real-world problems, but it takes these concrete real-world problems as the starting point of different projects. So why is COMSOC R&D important? Many of the collective decision-making problems that we encounter in the real world have these ad hoc solutions that are easy to think of and easy to implement and therefore commonly deployed. Despite this, many of these ad hoc solutions are provably suboptimal. Some examples include participatory budgeting, where many cities end up funding these projects that get the most votes, hence benefiting slight majorities while neglecting other parts of society. Another example is the allocation mechanism that the US National Science Foundation uses to delegate telescope time to researchers, which is provably not incentive compatible, meaning that researchers can benefit from misrepresenting their preferences. A more modern day application is reinforcement learning from human feedback, where evaluators' preferences over AI output is usually aggregated through the Bradley-Terry model, which corresponds to a voting rule that is not robust to cloning, which can be very important in text-based applications like RLHF. In all of these applications and many more, COMSOC R&D projects can significantly boost the quality of the output, while also introducing collective decision making into settings that do not traditionally have social participation. While comprising a relatively small fraction of current COMSOC research, there are already several success stories that demonstrate the power of the COMSOC R&D approach that we envision. In our paper, we expand on each of these success stories, showing how they made significant impact in settings such as participatory budgeting or citizen assemblies or the blockchain by designing and deploying principled methods for collective decision making. Importantly, in each of these examples, the efforts of the authors to deploy their methods created this positive feedback loop where theoretical results guide the methods that are being implemented, but the feedback they get from the implementation inspires new and exciting theory that is specific to the needs of that concrete problem. Unfortunately, these success stories remain relatively rare. To see why that may be, in the paper we expand on what we consider potential roadblocks to COMSOC R&D research under two main categories. Some of these roadblocks are more common to any applied computer science field, such as finding the right partners or maintaining operations, while some of them are more unique to COMSOC problems, such as the high-stakes decisions that are being made or the bias that implementers might have in favor of the status quo. While I won't expand on it now, we also provide potential remedies for each of these problems, both on the individual and the community level, which we hope will be starting points to tackling each of them. Finally, our paper provides extensive guidelines for evaluating COMSOC R&D work, which we hope will be useful for future reviewers of such work, as the factors to consider in such a review can be significantly different than those of reviewing a theoretical work in this field. In short, we believe that there's currently a disconnect between research on COMSOC theory and its applications, and we believe that COMSOC R&D projects is exactly what we need to bridge this gap. Thank you so much for your attention, and I hope you also join the COMSOC R&D movement.